Okay, let's prove by induction the math fact that the sum from k equals 0 to of k is equal to n times n plus 1 do that again, n times n plus 1 over 2. Let me just double check that that's the math fact. I'm pretty sure that it is. So that's something in your notes. You might look back and check that you need to know 1,000,000 seconds is equal to 11 days, 13 hours, and 46 minutes and 40 seconds, and 1,000,000,000 is equal to, let's see, 31 years, 259 days, 1 hour, 46 minutes, and 40 seconds. And remember, 1,000,000 is 1 times 10 to the 6th, and 1,000,000,000 is 1 times 10 to the 9th. Just something to remember. Okay, there are actually 5 facts, so you probably want to look at your notes to get those 5 facts. But back onto this example. So what we're going to do is we're going to show, so this is our what do we call it? Our theorem, right? That's our theorem, and we're going to do the basis. And so, well, so first, I guess before we do the basis, we're going to say that by mathematical induction for, or on n, we're going to do that, and we're going to do the basis first. And we need to show that we must show that, so we're going to say the sum from k equals 0 to n equals 0 of k is equal to n times n plus 1 over 2. Okay, so that's our basis. So what we're doing is we're saying we're going to take only one element, right? There's a sum, but since we're only going from k equals 0 to n equals 0, we only have one element of our sum, and that element is just going to be 0. And so what we want to know is it true? Like, does this actually work for just one element in our sum? Does this closed form work? So we're going to plug in n equals 0. So 0 times 0 plus 1 over 2. So we see that 0 equals 0. So it works for the basis case. And next we're going to do the induction hypothesis. And we're going to assume our theorem, right? So we're going to assume that the sum of k equals 0 to n of k equals n times n plus 1 over 2. Okay, and now we need our induction step. And so we must show that that the sum of n plus 1, right? So we're going to add an element to our sum. And so our induction is assuming that if we can add an element to our sum and it still works, then it's going to work for all. So n plus 1, right? I'm plugging in n plus 1 here into there. So n plus 1, and then I'm going to have n plus 1, plugging it in here too, plus 1 over 2. And so, so that's what we're trying to show, right? So I would put like a little question mark there. Is it actually true? Well, what I'm going to do here is I'm going to split this up into the sum from k equals 0 to n. So I'm going to say this is equal to, so I'm going to say that n plus 1, k equals 0 of k, that is equal to the sum to n, k equals 0, k. So I'm going to say this is equal to our hypothesis, our this, right, plus the next term, plus the n plus 1 term. So plus k to the n plus 1, right? And so I'm going to do that, and I'm going to plug this in. So I'm going to take this piece right here and plug it in for this, and then test to see, right? So I'm going to say, okay, so sum of n k equals 0, k plus k to the n plus 1, does it equal n plus 1 times n plus 1 over 2? Is that true? So what I'm going to do here is I'm going to go and right for this part right here, I'm going to plug in my closed form from up here. Right, I know that I'm assuming that that's true, so I'm going to plug that in. So that's going to be n times n plus 1 over 2 plus k to the n plus 1. Does it equal n plus 1 times n plus 1 plus 1 over 2? Okay, so what do we do now? This should be like this. There we go. Hmm. And actually, right here, instead of to the n plus 1, this is wrong right here. This piece, little piece right here, I'll go all the way back. This little piece is not right. So I did this wrong, right? So this is actually, this is just, all I'm doing is plugging in for k here. So I'm plugging in n plus 1. So this should actually be, this next term is really just n plus 1. Right? My thinking about the terms of this series, I'm going to have k equals 0, so 0 plus 1 plus 2 plus 3 all the way up to n. And then the next term is just plugging in n plus 1 for k, so it's going to be n plus 1. I'm going to fix that. Fix this one. So n plus 1, and then n plus 1. Okay, so now I have n. So I have these two terms, so I need to combine them. So what I'm going to do is do a common denominator. So I'm going to do 2, and so n times n plus 1, and plus 2 times n plus 1. Does that equal n plus 1 times, and now I'm going to write this as n plus 2, right? So this is just going to become n plus 2. Okay, now I can factor out an n plus 1 here on the left-hand side. So n plus 1, and what's left is n plus 2 over 2. Does that equal n plus 1 times n plus 2 over 2? And it does. So there we go. There's our induction. We show that our theorem is true.